Embarking on a new era of space exploration, America is now venturing into the vast unknown with the groundbreaking technology of spin launch. Throughout history, the challenge of achieving orbit has consistently revolved around the rocket equation. Indeed, the primary component required to propel a rocket beyond our atmosphere is an abundance of fuel, comprising over 90% of its total composition. However, what if the majority of that fuel is unnecessary? Looks like we're in for a scorching hot day with temperatures reaching 105 degrees. Step into the enchanting realm of the high desert, where a hidden valley in New Mexico awaits. Through imposing gates that appear to be plucked from the pages of a futuristic novel, an enigmatic object looms over the landscape, resembling otherworldly machinery. A staggering amount of 2.2 million tons of steel towering above the iconic Statue of Liberty. Indeed, this is A33, also known as Accelerator 33, boasting the largest diameter vacuum chamber in the world. The brainchild behind the spin launch is Jonathan Yaney, the founder and CEO. This system has a fascinating feature. It operates on hydraulics and has the ability to rotate as a whole. Yaney's company has been in operation since 2014, but the majority of the construction for this project occurred during the highly sought-after years. This idea is a fascinating blend of ancient and futuristic concepts. It draws inspiration from the Stone Age while being tailored for the modern space age. At its core, the idea revolves around the use of a sling. Imagine, if you will, a long time ago when our ancestors roamed the Earth. In those ancient days, they devised a remarkable contraption known as a sling launch system. This ingenious invention served a dual purpose. Not only was it a tool for hunting, but it also provided a means of survival. Picture our forebears, skilled and resourceful, utilizing this very system some 50,000 years in the past. It is a testament to their ingenuity and adaptability. Imagine a world where cutting-edge materials are seamlessly integrated, all contained within the confines of a vast vacuum chamber. Imagine this. There's an arm, gracefully spinning in a never-ending motion, powered by an electric motor. As it gains momentum, it reaches a point where it can effortlessly propel a spacecraft into the vastness of space. At that precise moment, we release it from our grasp, and in a mere 30 seconds, it gracefully glides through the atmosphere, venturing into the realm beyond. The carbon fiber tether in this instance serves as a mechanism to spin the launch vehicle rapidly or projectile, propelling it to a staggering speed of 5,000 miles an hour. This incredible velocity propels the car through an airtight membrane, propelling it toward the vast expanse of space. By utilizing this innovative approach, the need to carry excessive amounts of fuel, as is customary in traditional rocket launches, is effectively eliminated. When it comes to new forms of transportation, they always seem outlandish at first. Whether it's a suspension bridge, a train, an airplane, or even an automobile, they all have that initial element of craziness. Through a series of experiments, we have discovered new innovative methods that allow us to achieve the required speed. The operation of the tether necessitates a vacuum environment. Here, you'll find a collection of low-vacuum mechanical pumps that remove the initial amount of air. Additionally, there's a significantly larger high-vacuum pump that employs a completely different non-mechanical method to eliminate the remaining air molecules from the chamber. This enables us to achieve high vacuum, which in turn allows us to reach hypersonic speeds at sea level. When it's launched, there is practically no air inside, just a minuscule fraction of the atmosphere. Yaney drew inspiration from a 1960s U.S. military program that experimented with the use of massive guns to launch projectiles into space. Yaney's fascination with all things aeronautics, including flying, has been unwavering since childhood, despite the eventual abandonment of the program. Back in the day, when I was just a little tyke of 3, I found myself perched upon my dear mother's lap. With the controls in my tiny hands, I embarked on a grand adventure of learning how to soar through the skies. Throughout my life, I've always had a knack for soaring through sessions. Imagine soaring through the sky. As I gaze up at the vast expanse of space, I am reminded of our remarkable journey to the moon, only to be followed by an unexpected halt. We never returned to that place. It feels as if our civilization was once promised a grand expansion into space, but that promise now seems to have faded away. It turned out to be incredibly costly. It would be wonderful if we could grant them a victory. Perhaps you have the option to knock them over if that's what you prefer. Step into the depths of the beast as Yanni guides us into the heart of the launcher. As we made our way up, we reached the point where we could witness the mighty motor responsible for generating the powerful circulating force or torque. One may imagine a spinning shaft encased in a vacuum chamber with a seal that keeps the air out. This ingenious industrial system seamlessly combines various components to create something truly one of a kind. I wonder about the speed at which this shaft is spinning. Indeed, the shaft in this test facility will rotate at approximately 1200 RPM, making it fast but significantly slower compared to your average automobile. This brings us to the fascinating topic of projectiles, which will play a crucial role in transporting satellites and essential equipment into the vast expanse of space. A design that boasts a weighty front balanced by a light and airy back. It's a marvel of passive stabilization. Imagine a dart being thrown with precision, effortlessly gliding through the air following its predetermined path. Here are a few of the projectiles they have been utilizing, a third of the size of their ultimate goal: to travel almost 40 miles above the Earth. Once there, a petrol engine will activate, aiding in its journey to reach orbit. It's all about mitigating the risk associated with the core technology. It's a scene straight out of history, reminiscent of the Wright brothers' groundbreaking achievement. Just like when they took flight for the first time, soaring through the air for a few thousand feet and then a few miles. They may not have been ferrying passengers across the Atlantic, but this particular moment was undeniably significant. It served as proof that the technology was viable, paving the way for future scaling and expansion. One notable advantage of this transportation device is its complete reusability, which greatly simplifies the launch system and has positive implications for the planet. It truly captures the transformation of the space transportation industry into an electrified era. It's fascinating to witness the current trend of electrifying various transportation industries. However, rockets, by their very nature, continue to rely on the straightforward method of propelling themselves by expelling large quantities of combusted products out of their engines. Throughout history, employing a system like spin launch has been the primary method to reach space. It is crucial to reduce the carbon footprint of space access, making spin launch an essential solution. With each phase, the centrifuge has grown larger, and after 10 successful launches in New Mexico, the spin launch is already planned for the future. They are now considering a centrifuge 3 times the size of the current one, A33. In the final phase, the location for spin launch is yet to be determined. Speculating on when spin launch will actually start putting things into orbit, it is highly likely that we will witness their successful launches within the next 5 years. While I cannot make any promises, it is indeed an exciting prospect. It is quite remarkable to envision a centrifuge that is 3 times larger than their current one, reaching a height as tall as the Statue of Liberty. They have already spent $150 million on assembling what they currently have. They are considering an additional $250 million to construct an even larger version, which would complete the project. The cost may seem astronomically high, but it is likely much lower compared to traditional methods. One reason for the reduced cost is the approach they are taking, relying on equipment and satellites instead of sending humans. After all, humans cannot withstand the intense G-forces involved. It's quite fascinating, although attempting to replicate the experience of Maverick pulling 10 Gs in Top Gun may not be advisable.